Whoops. Alrighty. Welcome back to 105. Let me fix that real quick. That's not a flattering view. All right, there we go. So, welcome back to 105. So, before we get into today's lecture, I have the pleasure of introducing a demo from one of the fourth year groups here doing their engineering project. That they developed an AI bot called Alan to help you kind of navigate this course if you will find that helpful. So they have prepared a demo, so I will play that, and please give it your undivided attention for about 5 minutes.
Hello everybody, my name is Vaibhav.
I'm Ethan.
I'm Yassine.
I'm Abhishek.
And we're super excited to present to you Alan. You can think about Alan as a teaching assistant that's available to you 24/7, who can answer questions, whether that be syllabus questions or questions related to the course content. Let's get started. You can go to the Quarkus page and you'll see Ask Alan over here, along with the course ID, and you're going to need this while signing up. Let's go ahead and click it. And yeah, we're taken to this chat page. Let's ask him a question related to something you've been learning about. How do you convert an int to a double? And as you can see, Alan is generating a response with these citations inside, as well as these sources at the bottom. And this is because Alan grounds his responses in course content, but you should always verify Alan's responses by clicking any of these sources. Let's maybe click John's lecture slides. And this is the lecture slides about arithmetic. And if I scroll down, we will figure out this is how you convert an int to a double. And it also provides a lecture video, which you have the option to click as well. Maybe let's ask it to give us code for that. Okay, yep, so it gives us code for implicit conversion as well as explicit conversion. And to verify this code, maybe let's go to this lecture video.
Result of adding these two things. So again, this is a double plus an int.
And as you can see, it talks about implicit type conversion. Yeah, I'm going to hand it over to Ethan if you want to ask a few questions.
Sure. If I remember correctly, I believe Lab 2 is due soon, but I'm not sure, so why don't I just ask Alan? Okay, Lab 2, Alan says that it's due on the January 25th. Let's just verify it just to make sure. And as Salma has said, yes, Saturday, January 25th. Now, maybe you haven't started, although it is the 22nd, you probably should have. Let's just say, what is Lab 2 about? All right, it says that it's focused on more complex calculations with arithmetic operations and et cetera, et cetera. Let me just verify that. And yeah, it takes me straight to the lab handout that you should read before you start. Now I'm going to pass it off to Yassine. Maybe he can ask you a few questions.
Yeah. Let's assume you want to contact John or set up a meeting with him. We can ask it how to do that. How do I contact Prof. Ailson? Great. It says, it gives us his email address, his office, and it says that meetings can be arranged by appointment. Takes you to the syllabus. Always check the sources. And then we also have these feedback buttons, just a like and a dislike button. So I think this answer is good. I'm just gonna like it, and it helps us a lot with the feedback, just to figure out where we're doing well and where Alan can be improved. So please use these feedback buttons if you like or dislike any answer that we give. I'll pass it off to Abhishek to tell us about a very exciting feature that we've built.
So we've seen multiple examples where you have to look over sources. Suppose you don't want to ask Alan a question, you just want to get some direct source content. So what you can do is you can go into search mode and directly just look over APS105 content. So for example, you want to search up how to, like the same question we had earlier about typecasting. So let's say we search up typecasting. And then we get a bunch of responses. So this is just a quick way to search over all course content. This includes lecture slides, textbook, all of your professor's lectures, and a bunch more content that's available on Quirkus or CompNGG. And now, once we have all these search results, you can just go through and pick whichever source you want to go through.
Great. So sign up at askallen.ca, use the course code that's on Quirkus, and tell us what you think about it. Thank you.
Thank you, guys.
All right. All right, so that's what you have to look forward to if you make it to fourth year. Hopefully everyone does. And that could be one of your projects you do if you end up liking software. So feel free to use it, give feedback to the group. Again, they were in your seat, like 4 years ago. So let's continue on for the next topic. We are talking about for loops, which if we were okay with yesterday, it's really not anything that new. So for loops usually represent bounded repetition. And what does bounded repetition mean? It just means I know how many times it should actually execute. So it's not any more powerful than a while loop. It just allows us to express ourselves a bit better and kind of separate out what we're keeping track of for iterating the loop or how many times we should go through it versus what is actually going on inside the loop or the body of the loop. So the syntax for a for loop might look a bit more complicated, but there's a reason for that. We'll see shortly. But the syntax of it is keyword for. Again, keyword, I can't name a variable for. It is reserved for indicating the start of a for loop. Then parentheses, and then I can have an initialization statement is the first thing. That will only execute once. We'll see a flow diagram as well. Then we have our conditional expression, exactly like for an if statement, or in this case specifically, more like a while loop and the expression there. And then we have the increment expression here, which runs at the end of the body of the loop every single time. And we'll see how that works. And then it's followed by a statement. But again, as a word of warning, you should always just turn that statement at the end into a set of curly brackets that you can write multiple statements in. Otherwise, it will only execute a single line in the body of the loop, which is probably not what you want. So you should always write it like this with curly brackets. So how does the structure of the for loop or the flow of it act? Well, at the beginning, we can have some code right before it that will execute before we do anything with the for loop. Then what will happen is it won't check the condition. First thing it will do is execute this init code. So whatever statement is beside the bracket and the semicolon. So it will execute that exactly once. And then it will check the condition. And similarly to a while loop, if it is true, it will go into the body and execute all these statements all in a row. And then at the end of it, it will perform this increment, whatever's expression is here. So I don't have to remember to put it in. I kind of separate out my concerns. And then after it increments, it will recheck that condition. Again, if it's true, it will cycle through. Eventually, that condition should be false. Otherwise, I get an infinite loop, and my program does not work, and I have to press Control-C to get out of it. When it's false, again, just like the while loop, it just goes to the end. So everyone kind of okay with that? All right. So again, just so it's on the slides as well, I know I mentioned it yesterday, but just to catch up on the lingo, a single repetition of the loop, or when we go through all of the statements in the body of the loop, is called an iteration. You can also think of it as just a single step of the loop. So one way, well, it turns out that if we were for loop crazy, we now don't need a while loop at all, because we could write something like for and then empty, so that initialization statement could do nothing, and then that expression or that conditional statement, and then our increment can be nothing, and then we can have some code here. And that's going to be exactly equivalent to a while loop, right? It's not going to do anything special, because at the beginning, this for loop is going to do nothing, and at the end of executing this A, it's going to do nothing. So it's functionally equivalent as just while A. So if for some reason you don't feel you like while loops, you can now never write them again if you don't want to. The kind of style is if you know how many times the loop should iterate, you should use a for loop, and then if you don't, you should use a while loop. So you should never kind of write something like this. This is just to show you can write a for loop with missing things. So let's write a program to count from 0 to 9. So if I were to write a program that counts from 0 to 9, knowing what we knew last lecture, so just with a while loop, how would I do that? Anyone help me out? Yeah?
0 to 9, right?
Yeah, 0 to 9.
For int I equals 0.
Without a for loop, with just a while loop.
Okay. Int I.
Yeah, so we need an int I equals something, 0. Yeah.
Then start a while loop.
Then while
I is less than 10.
while I is less than 10. Oops.
Printf I with
Printf I with
the new line.
the new line, so I need to use the D format specifier, give it the I argument, and I do it in new line, and then this is it? This is it? Okay. Oh. Yes, so this is, so we almost forgot I++ at the end. If we didn't put that in, it just print out 0 over and over and over again and wouldn't stop. So we have to do something like this. So everyone agree this should count from 0 to 9? Yeah?
Plus I or I++?
In this case, that doesn't matter, right? Because the only difference between ++i and I++ is going to be the return value of that expression. It's always going to increase I. So let's say coming in, the first iteration of the loop, I is equal to 0, right? So both I++ and ++i, after that statement, I is going to be equal to 1. The only difference is going to be the result of this statement. So if it's I++, the result is 0. So it gives you the value of I before it increments it. And then if I did ++i, the result of that is a 1. But in this case, since this expression is just by itself, in an otherwise empty statement, I throw away the result, so it doesn't matter. So again, you probably shouldn't need to know that difference. If you write a program where that difference matters, you probably have written something complicated and very hard to read. So you should default to doing just ++i, just for performance reasons that you won't learn yet. All right, so if I do this, everyone agrees 0 to 9, right? So I can compile it, make sure that I save it. Actually, let's get rid of the comments, compile it, and then we can, it's called, oops, this one's called print stars. I used the wrong application name, but whatever. So this prints 0 all the way through 9. So I can do the exact same thing with a for loop because, as we just saw, we almost forgot to put ++i on there. And if we forgot, it would just print 0 and 0 and 0 again. So if I was to rewrite this in a for loop, the whole idea behind it is that this line, and this line, like this I equals 0, this I is minus or less than 10, and I++, all kind of logically belong together, right? It's all counting how many times the iteration of the loop should happen. So the first one is where it starts, the other one is how to go to the next one, and the other one is when it should stop. So the whole idea of the for loop is all of those 3 statements should be the only things modifying that one variable, and you can kind of keep track of it all together, and it's easier to know if you have screwed something up. So if I was to write this as a for loop instead, I can essentially make my code cleaner, separate out my concerns. The body of my loop is just going to be concerned with printing the value and using it. So I could write for int I equals 0, so that's my initialization statement. That will only happen once. Then next, and you just learn this from repetition. I don't know. I've done this so many times that I just immediately do it. So the next one is our conditional. So in this case, it would be we want to continue while I is less than 10. We want to stop at I is equal to 10. So if I is equal to 10, that's false. That's good. That's when it stops. And then finally, plus I. And then I can just move the body here. And now this is a bit easier to read. I don't forget anything. All my changes to I are on the same line. I kind of separate out my concerns with iterating versus what I'm actually doing. So this is what most programmers do to write something that we know will iterate a certain number of times. So we can see if we run that program again, it prints 0 through 9. But you should always prefer this if you have a bounded number here. So any questions about that? Cool. Little, as we call it, syntactic sugar. So it just kind of pretties things up a little bit. The other nice thing it does, the only actual change that we'll get into later is if I were to use, try to use I here, I actually get a compiler warning, right? So it says I is not defined in this case, like it can't find it. Because it also gives us some protection, we should only be using I inside of the loop. And if we use a for loop, then the compiler ensures that we can only use I inside the loop and we don't accidentally use it outside of the loop. So here it says it's undeclared. While if I had a while loop or if I wanted to use it outside of the loop, I can still do it with a for, I just have to declare it outside. So I could do something like that. So I could declare it outside. This statement will still run only once, so it still will initialize it to 0. But I get the final value of I here. So this would be like the final value of I. So if I did that, the final value of I should be the last value that made this thing evaluate to false, right? And made us skip to the end. So in this case, I should be equal to 10 if I run it. So if I run it, it says the final value of I is 10. So I could do something like that as well if I wanted, but generally you only use the variable inside the bound, so I would declare it here and just make everything nice and tidy. And then that way, if you try and use it outside, the compiler yells at you, and you should become friends with the compiler because, believe it or not, the compiler helps you from making a lot of errors. All right, so any further questions about that? We're good? All right, so next thing we could do, not much of a leap, but we could write a program to print 15 stars on a line. So if we were to do that, how could I do that easily using my fun for loop? Yeah?
So change the I is less than, and instead of 10, we have 15.
Yep.
And then in the print, you just put a star and then take out the new line.
And that?
Yeah, take out
Yep, so that would print 15 stars. Typically for nice programs, it should always end with a new line and always end exactly once. So at the end of my loop, I should just print a new line here too at the very end, and then I'm guaranteed that there's one new line after all my stars. So anyone disagree with that? So compile and run that, boom, I get 15 stars. So it kind of helps us. And you'll see that the bound starts at 1. We're not using the value inside, or sorry, the bound starts at 0, and we're not using the value inside the loop. So turns out computers like starting from 0 because computers usually use that number to represent the distance between things, and 0 means you start at the beginning. So computers really like that. Sometimes if we're doing something in English or you're thinking about it, as a human, you might want to start at 1. In this case, I could start at 1. If I were to start at 1, I would just have to change my loop bound. So I can start I at 1. But if I wanted to make sure that this still loops 15 times, I could do less than or equal to 15. So while I'm going through this loop, the first time through, I is equal to 1, then 2, then 3, then 4, then 15. And then as soon as it hits 16, then it exits the loop. But both of these will do the exact same thing. So questions about that? Okay, so I think this might be on your textbook. So there's some weird thing here. So this expression here, I could actually take advantage of that running every single time. And there is an operator called a comma operator. Hopefully you don't have to use that, but I'm only showing this because it was shown once in one of the exams for some reason. So if I wanted to do the exact same program, I could actually write this. So I could put printf here, and then a comma, oops. And then the body of my loop does nothing. But this will do the exact same thing as before. It is just very weird, and I completely recommend against it. But what that will do is it will still follow the format of a for loop. So this will execute first. Then it will check this. OK, I is equal to 1. It's less than or equal to 15. And then it will do nothing. So the inside of the curly brackets, there's nothing. So it will do nothing. And then at the end, it will always do this increment expression. And in this case, the increment expression, it doesn't have to increment. It can, I guess this is to show it could just do whatever you want. It would do printf, and then it does a comma to tie. That's a way to tie expressions together. You shouldn't ever really use a comma for expressions, but it exists. It's very confusing. And then after that printf, it will do ++ I. So I could do that. And if I compile and run that, whoops, if I know how to spell compile, it will actually do the exact same thing. Again, I'm only showing this to you because, I don't know, it was a short question on your exam or something like that. I believe this is before when the course was run by someone that just liked weird C rules that you will never, ever, ever, ever see again. So for the most part, forget I just told you that. This is in case you ever see it, or in case you see very bizarre code, because there is actually what some people find fun, just to write very bizarre, hard to read C code, and that's like a hobby for them. So you should write it something like this. All right, so other fun things we could do is, they're not officially taught in this course, but especially if you know other languages or you want some flexibility, there are certain keywords you can use in a loop for more control. So you can use a break statement. So you just say break and then a semicolon. And then that causes the current loop to immediately stop and go to the end as if that expression was false. But it will immediately jump from that break to the very end. Do not pass go, do not collect $200. You can also use a continue statement. So a continue statement in a loop stops, doesn't execute the next statement after that. Instead, it resets and goes all the way back up to that expression and will recheck that expression. So it's a way to kind of say, OK, I've done enough in this iteration of the loop, stop, go back to the beginning, but still check that expression again and see if we need to go again. So these statements are more advanced. Coordinator does not encourage them for this course, but they're there. You are allowed to use them if they have been told to you. So here's me telling them to you. So other ways I could write that, other ill-conceived ways, if I wanted to, instead of having this conditional here, if you just leave it blank like that, so the other rule is if you just leave that conditional blank, then C will assume that that's always true. So this is an infinite loop that will just keep on going over and over and over again. But if I wanted to utilize my break statement, I can be like, oh, well, when do I want to stop? Oh, maybe I want to stop when I is equal to, again, remember, for equalities, we have to use 2 equal signs. So if I is equal to 15, then maybe I can break. And this will also do the exact same thing. It is a bit uglier. It takes up more room, but it is functionally equivalent. There are lots and lots and lots and lots of ways to write the exact same program. Just others are better than, some are better than others or more readable. So I could do this exact same thing here use a break statement instead. Yep.
What if you have a nested loop and then you put break inside the inner loop? Would that also break out of the outer loop?
Yeah, so that's a good question. So if I have a loop in a loop and I'm going through the inner loop and I put break there, the question is, does that get me out of the inner loop or the outer loop? And the answer to that is it only gets you out of the current loop you're in. So it would only get you out of the inner loop. Yeah?
Sorry, could you recap how the for loop changes if you put the plus plus in front versus behind the expression?
So here, if I change this to this, it will not change anything because it doesn't use the result of that. It just uses that to change the value of I. So, yeah, number of loops won't change, just to make sure. So here, I'll reset everything. So I'll do this. Let's go back. So we go back all the way to the beginning where I was 0 to 9. Just to make sure, I'll just do I equals instead. So if I do that and print stars, I'll see I equals 0, 1, 2, da, 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 da. If I change this from plus plus I to I plus plus, it shouldn't change anything because all that C cares about, it just runs this right after the body of the loop and it doesn't use the result of it for anything, right? So in this case, all we care about is that it changes I. If we compile and run it again, we get the exact same thing. So in this context, it really doesn't matter. It's more of a style thing. So I think your coordinator prefers I plus plus. I prefer plus plus I. You can use whatever you want. In this case, it doesn't matter. A case where it does matter and something weird might happen. So this will be a case where it does matter and weird things happen. So here's a good example. So can I write this? Well, I can compile this, right? Anyone might want to guess what happens if I run this? Yeah?
So is it going to increment I first? So it's going to it's going to become 1 is less than 10. And then it's going to print that, so it's only going to print 9 times.
So it's only going to print 9 times. What values is it going to print?
1.
Just 1?
Like it's going to start at 1 then 2.
So what's the last line it's going to print? So it's going to start at 1? So it will start at 1. What will it end at? 9. All right, well, let's just compile it and see. So this is going to be a case where it matters, and if you write this, you probably shouldn't. So if I do this, it goes all the way up to 9. Okay. That's kind of what I want. The only difference from before is that this doesn't start at 0 anymore. It starts at 1. And why is that? Because, well, first initially I is equal to 0, but then remember this conditional gets checked always. It gets checked first. So plus plus I will increment I from 0 to 1, and the value returned will be 1. So 1 is less than 10, so it will print I. Then it'll keep going through it over and over and over again until eventually I is equal to, when it gets up here, prints I is equal to 9. Then it would do I plus plus. That would make sure that, hey, I'm updating I from 9 to 10, and it returns 10. So 10 is not less than 10, so it's going to exit. If I instead did plus I plus plus, am I going to see something different? Yeah.
It'll go from 0 to 8.
0 to 8 instead? Okay. Anyone else? Were you going to say the same thing?
No, it'll go from 0 to 9.
0 to 9. Anyone else? So we got 0 to 10. Yeah. 1 to 10. All right, we got a whole bunch of answers. So that's good. That means it's something we need to learn and we can argue against. So if we do this, we get 1 to 10. Exactly. Why is that? Again, it's the difference between, in this case, the difference between plus plus I and I plus plus matters. So first time through, when I is equal to 0, we're going to do this first. Plus plus I plus plus will change the value of I from 0 to 1, but I plus plus returns the old value of I. So the result of I plus plus is the old value of I, so it returns 0. So 0 is less than 10, so that is true. It'll go through over and over and over again, and then when I is equal to, let's say, 10 in this case, if I is equal to 10, whenever it prints this line, or when I is equal to 9, let's say that. So when I is equal to 9 and it goes to recheck this condition again, it will do I plus plus, which increments I from 9 to 10. But the result of I plus plus is the old value of I, not the new value of I. It's the post-fix version. So it will return the value 9, even though the value of I has been updated to 10. So 9 is less than 10, and in this case, it will print off the current value of I, which is equal to 10. So this is the case where it matters. If you write code like that, you shouldn't, because it's confusing, right? Like the old way I wrote it, when I wrote it like this, it didn't matter what if I wrote plus plus I or I plus plus, it didn't matter. Everyone in the class knew exactly what it was going to do. But when I wrote it the confusing way, then only like a fourth, based off that little sample size, actually figured out what it actually printed. So your whole goal is to write very clear programs that you can look at a glance and know what they do. If you put the plus plus I in there, or use it plus plus as any part of an expression, it's confusing. And when I used the postfix version, it actually did what we all expected it to do. But when I did the prefix one, it did what we all expected it to do. But when I did the postfix one, it was confusing. So that's why I say never, ever write the postfix version, because unless you exactly know what you're doing, you're never going to remember the stupid rules. It's confusing. It's like the principle of least astonishment. You don't want to surprise yourself. Surprises at birthday parties are fun. Surprises for code are not fun. All right? So I could also, write nested programs if I want. So say I wanted to write a program that printed off something like, I don't know. Say for practice, I wanted to write out a program that did like a triangle of stars like this, of like 5 rows. Well, one thing you might do to figure out, oh, how should I do this is, try and assign things to numbers and figure out how many times you should do something, and then, hey, you'll probably have a good idea for a for loop. So in this case, if I'm printing off a triangle of stars, well, the first thing I look at is like, hey, it looks like I'm printing 5 rows. So maybe one for loop should be doing printing a row. So I could call them, let's say we're using English, I could say this is row 1, this is row 2, this is row 3, this is row 5. So that kind of looks like I need a for loop to print a single row. That's usually for loops, only one number is changing at a time. So in this case, maybe I need to have a loop to go over the row I'm printing. And then later, I also need to figure out the number of stars. And it seems to be changing, but it seems to be related to the row I'm in, right? So in this row, it's just 1 star. On this row, it's 2 stars, and it seems to be equal to the number of the row. So again, lots of ways to write a program, but for this, since I thought of it as, starting at 1, I can have a loop that starts at 1. And maybe this will require 2 loops, so this will require a nested for loop. So usually by convention, if you just have one loop, you can name the variable that changes I. If you nest them, maybe you name the inner one J. But if you can come up with a better name, maybe you should use that. So in this case, I'm going to call the variable row because it represents what row I'm printing. And if I want 5 rows, I can do something like that, right? So now the body of this loop will run 5 times. So the first time row is equal to 1, then 2, then 3, then 4, then 5. Now all I have to do is print the number of stars that corresponds to the row. So I could do something like, I don't know, create another for loop that starts at 1 and I is less than or equal to the row, right? Because I only want to print the number of stars that exactly matches the row number that I'm currently on. And this is just taking advantage of what we did before. We knew how to print at 15 stars, so we can figure out how to print row number of stars, right? So here I would just print a star like before, and then at the end, I would just have a new line so that all my stars are on a new line. So if I compile and run this, I should see my handy dandy little triangle. And whoops, this should start at 1, not 0. So I get my handy dandy thing of stars, right? If I wanted more stars, boom, all I have to do is increase this. So I can just increase that from 5 to 10, and boom, I get more stars, and it looks pretty. And I don't know, usually for exams and stuff, they have you use 2 for loops to print all types of weird patterns and things like that. So questions about that? All right, so more fun things I can do with for loops is usually you don't print off something like this. Usually you have like rows and columns and things like that, and you can treat things as like a grid. So let's go back a little bit. Let's start at 0 instead of 1, and we'll do something in like rows and columns. So say I want to just do something like just rows and columns and make a 2D grid. So I can do something like that. So say I wanted to print off a cool, I don't know, a cool grid of numbers where it just shows me the number for every spot that starts at 0. So just like a 2D grid, 0 to 9, and then the next row is 10 to 19, then the next row is 20 to 29, something like that. So how would I do that? Any guesses? Yeah?
It would be row times 10 plus column.
So I want to print off row times column.
No, row times 10 plus column.
Row times 10 plus column. So something like that, and then I can print the new line at the end because, well, a row should end with a new line. So if I do that, it looks a little bit ugly. We can pretty that up, but that seems to be right. Right? So we got 0 through 9 at the bottom. We're taking advantage of, well, in this case, this will print a single digit, right? If call goes from 0 and less than 10, it will go through 0 to 9. So it will basically just tell me the ones column. And then if we're doing that numbering, the row number, consequently, actually addresses the tens column. So this gives me the digit for the tens column. So if I want to turn that into some number, like we learned in elementary school, it's just that number times 10 plus the column, that gives me the full number, right? If I wanted to pretty it up, I could use my format specifier to make sure, to make sure everything is 2 characters wide because that's the widest character. So that will get me something that looks like that. Maybe that looks a bit, maybe I do a leading 0, so it's just all full of numbers. That looks kind of ugly. How would I make that a prettier grid? Yeah.
Because
Yeah, get a space, which is so how would I get a space after every number? So how would I do that? So just put here, just put a space here. So that will get me, it will look correct, whoops. So it'll do something like that. But I'm a stickler for the rules. So the rules say that you should only have spaces between characters, right? So I have laser eyes. I know there's a space here after that 9, and I do not like that. So how would I make sure that that doesn't happen? Yeah.
The tab thing, like the \T.
The tab thing? That still introduces a tab character. So that would put a tab after each line instead, right? I just, yeah, but I would still have one at the end there. Right? Yeah.
You could change the inner for loop to go up to 9, and then in the outer for loop before the \n, put your last number, which is going to be 10.
Yeah, so I could do one change of maybe I just go here, change this to 9, and then print my last number here, which would just be when call is equal to 9, something like that. I'm kind of repeating myself a bit there. Like I have 2 print statements that look exactly this, pretty much exactly the same. Say I wanted to change it to be, I don't know, 3 characters later, then I have to remember to change 2 spots. So it works, but I might be able to do something better. Any other ideas for something better? So what is a type of construct that will allow me to skip something? Because sometimes, right, I'm printing 10 numbers here. How many spaces do I print? 9, right? There's 1 less. It should be between everything, so it's 1 less. So in pretty much every case except 1, I should print a space, right? So how do I conditionally skip over something? Uh-oh. An if, right? So if I wanted to do it, how should I write my if? So I should either in this case decide whether or not I'm deciding to print a space before or after the character. How do we want to do it? Do we want to conditionally do it before or after? Before? So if I wanted to conditionally do it before, after? I mean, it doesn't matter which, right? Is one harder than the other? We could do both. So you want after? So if I do after, it's something like this. So now I want, if I did this, this would be exactly the same as before where I had that space at the end. So now I think about, hey, when should I skip this? So I can use an if statement and think about when I should skip doing this, right? Because if this is false, I want this to be false when I should skip over it, true if I shouldn't skip over it. So what should I put in these brackets? Yeah.
Call is less than 9. Wait. But then shouldn't for the outer for loop?
Oh, yeah, we need to change that back.
Yeah.
That? Yeah, so let's see. So we compile it, run it. It's not exactly clear, so to debug, maybe we can change this to an X just so we can see it, just to make sure we didn't mess it up. And we can see that indeed there is nothing at the end there. So that is one way to do it. There is more than one way to do it. Some might be better than others. Some might not matter. So, you know, if I decided to do, I don't know, 11 columns instead, I would change this, right? And then I would have to change this, and then I would have to change this. Kind of a pain. I could, however, one slightly nicer way to do it is I could figure out what the condition is that I should or shouldn't print the space before the character. So if I think about it that way, should I print the space before the first character, yes or no? No, right? So if I wanted to skip that, I could just do if call does not equal 0, right? As long as call does not equal 0, I should print a space before it. So this is another way that will work. So I can see here that indeed, if I change that space to an X just to verify, that indeed I do the same thing. Doesn't matter, 2 ways to do it. This might be a bit better because if I wanted to have more numbers of the column, I don't have to remember to change that one. So I could do something like that. In this case, maybe I need to make it 3 wide instead just to look nicer, but I could do something like that if I wanted to. Don't have to remember to change that number if it's always 0, if it's always the first one. It's a bit easier. Or, of course, I should really just be not using magical numbers. I should probably do something like say k, make a variable called const. In this case, I'll use this format just because I like it better. So I could do num calls, so is less than num calls. And then if I want to do the space before again, I could just do does not equals num calls. And then in this case, I just do -1, and that makes it more general. Then I only have to update that number in one place. And then I don't have to remember that. So that's another good way to use variables. If numbers are related to each other, and if I were to manually change it, I have to change multiple things, probably tells me I should use a variable. So now if I do that, I can just change it in one place, and everything updates nicely, well, except for that. Everything updates nicely, and I don't have to worry about it, right? So this will work no matter what. Even if I change the num calls to 9, boom, should still work like that. No problem, don't have to remember to change anything. Again, doesn't really remember, in this case, doesn't really matter if you skip before or after. It just changes the code you have to write slightly. And again, it's programming, so there's more than one way to do things. All right, any other questions before we wrap up? All right, so you should be able to finish Lab 2 this weekend. Well, you kind of have to. So good luck on Lab 2.